Haben Sie sich schon mal gefragt, wie wertvoll Wasser für unser Leben ist? Wer sorgt eigentlich für perfektes Wasser bei mir zu Hause? Wer nimmt den Kalk aus dem Wasser, damit meine Dusche sauber bleibt? Und wer mineralisiert mein Wasser mit Magnesium für die Vitalität, die ich Tag für Tag brauche? BWT macht das. Für mich. BWT. For you and Planet Blue. Magnesium für die Vitalität, die ich Tag für Tag brauche. BWT macht das. Für mich. BWT. For you and Planet Blue. Magnesium für die Vitalität, die ich Tag für Tag brauche. BWT macht das.
Um, hey, yeah, I just wanted to make a normal map rotation thing. It's just a small thing. I always already figured it out how to make it, or how I solved the problem, because yeah, I think it's pretty close to writing shaders in this case. Yeah. So we won't do a texture today. It's good. Yeah, starting with some names. Yeah, everything is just not important. Okay. Just starting with, yeah, I just put this in. It's, by the way, my non-uniform pyramid thing. I can just move the pyramid where I want to have it. Anyways, I want to make a normal map out of it. And add a base material to visualize it. So yeah, just okay. Now we're going to make a graph to rotate this thing. Maybe I will just import some model to just adjust it to the tangent space or something else. Yeah, to have some automatism to maybe just add multiple versions or color versions of the same thing, but I think Substance Painter is pretty much it's better for this. Yeah, I'll start to do it. A third thing. Wait, this. Okay, I have to go into the graph because it's somehow clamped to the fourth time of it. It's relative to parent, so yeah. Okay. This won't work somehow. Oh, okay. Relative to parent. The parent is relative to parent. What's this? Okay. Okay, now it's 512. Yeah. What I will do is just creating first a texture 2D node and increase it by 2 times of the original size to later on just having it somewhere in the middle that I can rotate it. Let's see what I mean. Yeah, we make it 50 and 50. That's now the center of this one is now 512 to 512. Okay, that won't help. The idea was, okay, I have to first rotate the this one to make a normal out of it, then just do the same job again and rotate it in the opposite direction with the normal map and get it out. So that's pretty much everything I have in mind to really do it. Because when I now rotate it, you see that it won't change. Okay, it's the wrong material. So I need to go into this one and just visualize it, and you see it's just changing the normal. Okay. What I do is to the very important thing is to have a rotation matrix that do the job for you. So a simple two-dimensional rotation matrix, and it's pretty simple. I just will add a first I will add a input manager and add a I want to have a float, and it's the angle float. I know what it returns, but min is 0, max is 1. So when we go here into the rotation matrix now, expose. No, console. I want to create an empty function for it. So we need to return a vector float 4. because we have scaling and rotation. No, it's not scaling and rotation, but we just, I don't know why it is like this is a math thing. To rotate it, you need to have 4 dimensions, and you can also add scale to it. Okay, let's go and try vector 2. Vector float 2. So because we want to mix it later on. Okay, we have now X, Y, Z, W, and we have an input. I don't know how I named it. Oh, I named it input. Okay, I just name it normal rotation. Here it's a float, it's angle, and we label it as rotation. If someone don't know it, this label is just auto-generated out of this, but I won't show normal small to rotation. I want to have only the rotation thing. That's only shows. You can add a description to it. Rotate the normal informations, or the informations out of the height map. Okay, so we have this thing here, and we now add variable. We want to get a float, so we use the float on normal rotation, and if you just if you understand that you have this, what the fuck? Okay, this sinus curve. You see it? The sinus curve just runs from P0 to P2. So from 0 we have to multiply it by P 2 times, so that we get this that we get the rotation right. Yeah, okay. Okay, just I know if there is a P. We multiply it. But we multiply it 2 times. So unless, like, okay, we add a float. Okay, what do you, not a float, 2, a float. And we want to have 2. Okay, now we have just simply our input value from 0 to 1, and we have P and multiplied 2 times, and the result is our curve. Remember, the curve is just like this, just because we want to have a rotation from 0 to 1. That's the theory. Now we have to add a rotation matrix, and this is like usually a 2-dimensional rotation matrix. Is like you have cosinus and sinus, and you also have a negative but this is first we have the first one is the cosinus out of our value. The second one is the negative sinus. So there, yeah, -1. So it's he just multiplied it with -1, so it gets negative. So I get here just this is our second value. Then you already see that here's going on something. When I just apply the values, it's nothing. It's just 0.5. The first one just makes it like that, because our value, our normal rotation is 0. It's getting like in the horizontal, it gets straight, or it gets mapped in the horizontal. Now he's just adding it, the scale to it, and now it's in a different position on the horizontal axis. And yeah, it's like, and then we have sinus A, sinus, and cosinus. And somehow I made a mistake here. Let's check out if it works how I expected it. Okay, you see it makes some strange things. Maybe I've made some mistake in the math, but usually it's okay. I will try 1 minus. Okay, I multiply it. So multiply the value by a float that's -1. So maybe the -1 is just to invert the value, but I want to set it as -1. And now you see it looks pretty good for now. And now I just rotate it. Here you see how it works. Okay, and later on, if it's done, I will just try to set this set the size of it, so to have a scale. But maybe I do it in 2 different texture 2D coordinates. Maybe I can move it in this one here. Add node. So sorry, it's pretty mathematical at the moment, but this is what Substance Designer is. In my case, it's pretty much math. Okay, let's try to add scaling to it, or maybe you can use it not only as a rotation of a normal map, but this is just a general rotation thing you can use in whatever thing you want. Yeah, it's pretty cool. So I remember, or just I go into my texture 2D node. Wait, non-uniform pyramid. I just close this. Close the non-uniform pyramid. Okay. And when I remember here, I go into this one, and when I go into my matrix, and I see it multiplies it 2 times. When I get it to 1, it's right. So it's the x value and the w value. It's just multiplied by the value. It is negative scaled. So it is this value and this value. As I remember these 2 values, yeah. Okay, now I need to have a math that I just increase the value, the slider. Maybe I make a slider from scaling 1 to scaling 0.5, or just make it from 0 to 1. So I want to have a scale value. So let me first introduce this value in the Explorer into the input parameters. So I want to have a scale. Yeah, let's call it. Let's make out of this not a normal. We call it a different type of texture 2D node. Yeah, the normal texture 2D node is, yeah, have already these features, but texture, we call it a uniform scale. So maybe we add a switch later on where we can say, okay, we want to have a uniform scale and a non-uniform scale, so that we can switch between different options in this texture 2D node. Let's go and figure out some things for this. Okay, we have a texture scale, uniform scale. It's from default. Default is 1 to 0. Okay, we just now we make a math. We say we take a float. I'm not that good at math, sorry. We take a float, make this by 1, and divide it by our float value. So when we 1 divide by 1, it's 1. If we 1 divide by 0.5, it's 2, and so on. So, but we are not able to divide it by 0 because then we crash the app. So we have to add a clamp or something. I don't know if there is a clamp. Okay, I have to find something. Okay, I will take an if else, and we take it's more. I need to just check it where it is. Okay, comparison. We have a greater, so it's always greater than 0. We get our gut float, and we want to add the uniform scale to it. Okay, we have if the uniform scale is bigger than greater than 0. If it's greater than 0, then make this true, and if it's true that this is greater than 0, then pass this, and if it's not, paste 0.001. Or just make it 001. Yeah, okay. Hopefully it don't crash. And we divide 1 by this output, and just this one we multiply it with this value, so we put it up there. Okay, now when I just go into my rotation matrix, you see now I still have the 50% thing, but we go into this, and to see if we going right with this. So I got the rotation now. The rotation works pretty well. Whoa, turns 1. Turns what? This? Okay, because of the multiplication, you do something that he don't want. And the texture uniform scale do not work. because texture rotation, that was the wrong one. Okay, uniform scale. Now try it again. Let's go and just preview this one, and we have the uniform scale. Okay, it works for the one direction, and when I now rotate it, yeah, you do some stuff because we only apply it to one direction, and the other then gets confused. Let's do it by a default value. Let's do it for both. For both settings. So we have the same value, and we just duplicate this. So we have this already, and we go in and just we want to have the cosinus of it. Oh, we already have it. Okay, let's plug that in. So we have two multiplications. This is our graph for the scaling, and now we getting something, I think. Oh, let's call this just simply rotation. Okay, we have the parameters here, and we get the scale, and what? Okay, we need something else, because when it's like this, we get different rotation out of it. Maybe I need to add the sinus curve to it. Okay. Okay, let's try. Okay, we have the cosinus curve and multiply with it. That works when it's zero, when it's 1 or 0, when it's 1 or 0.5. So it's always when it's getting P. We try the same thing with this input here, and just paste it into this one. I don't know what if it's work, but we tried. Okay, let's go into the rotation. Yeah, now it works. So now we have rotation, and we have a uniform scale. I thought of adding a non-uniform scale to it, but this is more complicated, because when I now want to scale it in different proportions, I don't know how it gets, but yeah, we have the uniform scale here, and we can go with something that is different. Okay, maybe it is. No, we keep it like this. Now we have scaling and rotation, and now we have this rotation here. We want to have a negative on this one, so we want to scale here and just make the opposite rotation over there. Or the inverse rotation. So now we have it 2 times, but we want to inverse the rotation. Therefore, it's simply to multiply this one by our -1. Where do I have it? Here I have the -1. I just duplicate it. Okay, so we have it. So now you see it's still in the same position, but we just have the rotation in a different order. When I now go into, I have the scaling in it. I don't want to have the scaling, so in the later process. So make these connections back here, so that we don't have the scaling anymore. Just smalling it down. Okay, so what we have now is pretty much the rotation thing. When I go here I will save that. Okay, you now see that I rotate the normal here and get the result here. Let's try to go into our normal map. We can review that here. I don't know where these things here come from. Maybe it's because of the size. Yeah, we also rotating it here. Wait, I need to just first check something, or I just make a texture 2D node. A transformation 2D node, and this is okay. This keeps 1 by 1, and this keeps 1 1. Okay, what I do here is now I just make it 50%, 50%. Oh. Okay, so that I get the size to rotate it, and just increase the size 2 times so that I have 124. Now I hear these are all 124, and in the end I just reduce the size again, again with the transformation 2D node, and say, okay, you are halfway there, but we have 200% of the scaling, so we scale it up and scale it down again, and so we should get the right rotation. Somehow this one, okay, scale it up. Okay, because of the scaling here in my normal map thing, I just put it back to 1, and then we have the rotation here, the asset back in the right position, and we preview that. Okay, now you see it looks kind of strange, and that's what we want. I get now into the normal map direction and just playing with the turns. You see how it turns. It is pretty strange. You get some really weird effects. I don't know where you can use it for, but it's a funny thing to play around with. Maybe we should get some more direct lighting. Where it is good, maybe this one. There was a really good. Okay, this is relatively direct, and we rotate it by 0, so we get the pure. Let's go and increase the normal by 100. Maybe just let's add the height map to it, so that we see some kind of effect. Tools default added. 5's not enough. Let's go 10. Okay, now it looks like reflection, like the right reflection. And now we're changing the normal and see what it get. See, now we have the opposite thing. It's like it's reflecting the wrong thing. Let's go and just with the cylinder. Materials default. Let's make tiling by 2, and we do not scale it. And let's center this. And we now rotate it, maybe okay, let's go with something else. I usually rotate the reflections in some strange ways. For what you can use it, I don't know. Yeah, it's was a short thing, so maybe we can go now and bring some models in, and yeah, what should I do with it? I don't know. Yeah, so I think that was a cool graph. I don't know what I can use it for, but let's output it and set an input. Let's just generate a graph from it, and we name we take this one and we call it just, yeah, this is the normal map rotation. Maybe I'm able to make a better Transformation2D node by using my thing here, and I can work with it in a different way. So yeah, let's go with my Transform2D node here, the cool one, and just, yeah, we can see what we can do with it. We copy paste it, just create a new graph, transform to advanced. We call it advanced. Yeah, relative to parent, because we want to have a relative value. I don't know how to get different inputs from color or not, but anyways, it's not important. Let's check this out. Okay, I copy paste it, and I will now add a new Transform2D node. Because I want to add the non-uniform scaling before rotating and after rotating. And just set up the graph first. I want to have an input image, input grayscale, input color. Okay, I do not know what I should how to get this, but we first go with the input, the grayscale input. This we leave it empty without any action. You go into the rotation and output the result. What could be cool is also that we have the transform rotation. Yeah, when I rotate it, to not get the cutting in it, or just keep the tiling. We will later fix this tiling mode, because I think that we will lose the tiling if we rotate it in non-uniform angles. But this is something I expect. Oh, you see, it's pretty complicated Transform2D node. Anyways, the offset, do not do anything at the moment. We will just add it later on, maybe. I don't know if we can add this this thing here later on. Maybe it's okay if we have something that drags in the Transform2D node. But first we go with this input, output, and we just copy these things here. We copy them. Sadly not. Okay. Normal map rotation. Okay, can we cannot copy them. Okay. The first one is the texture rotation. And we can set up groups. But yeah, for example, rotation. This is pretty interesting because then they make a drop-down menu for you to make several setups with it. We add a rotation and we copy the texture uniform scale. Because later we add another texture scale. So this is a texture uniform scale, it's a slider, and here we have an angle thing. Rotation, and you get the group scale. Uniform scale. And if you just use the label, you can have spaces. I don't know if you can have spaces with the identifier, but from programming side, it's pretty bad to make to add spaces to your identifiers. Okay. That's, I think they describing it by itself. That's okay. Visible if we will use this later if we yeah, let's edit at these things. We make a bool, but we move it up over the scale, and we make a boolean, and we call it non-uniform, or use uniform scale, or we can call it scale mode. Okay, we have two labels, label true, label false, and we call it scale mode. And we have label true. It's when it's true, we have the uniform scale, and if it's false, we have the non-uniform scale. We have the uniform scale and the non-uniform scale. Let's make it with capital letters. It looks better somehow. Maybe it's because I'm German. Non-uniform. Okay, non-uniform scale, and that's all. And we say if input let's these brackets, and we say scale mode is true, then show it only if scale mode is true. So you see it's you have to type it by hand to visualize it, but now I go into my normal rotation and I just drag the transform rotation in to see, okay, it's a non-uniform scale, and when I change it to scale mode, I get a scale. But you see, I do not see it in the group. I want to see it in the group, in the scaling mode group. So I go back into my settings here and say, okay, the scale mode is goes only also to the group of scale. I want to have the scale group, and now I go here and into the other graph, and I see when I open scale, I can switch non-uniform and uniform scale, and I have the uniform scale value. I can also later add several things, like I want to have the scaling that it fits always into the frame of the texture, so that when we have it rotated on 45 degree, we get these nice fitting into our texture space, to maybe get rid of clipping or something if we use a splat map generator or some type of generator, brick generator or something, that we don't get cutted edges, that we get a smooth, perfect overlaying thing here. Okay, let's okay, we have the uniform scale, and when we go with the uniform scale, let's add this in. Oh no, we want to add this one, because the color input do not work at the moment. I don't know how they make this automatic way. I need to figure out. But when I just now add the uniform scale, you see, I can add, just when now it's tiling, but we do not get the tiling of this one, so I need to disable the tiling mode, absolute, no tiling, so that I get the right scaling here, you see, and also the rotation works like we did before. Now add a non-uniform scaling to our math here. So we say we make different if variables. We do not want to multiply this. We can do it by this, to multiply always the same value. We go here and we say make a new if variable, if else. So okay, and we get the boolean, and we just select our scale mode. So if the scale mode is true, if we have the uniform scaling, we use this path, and if it's not, we use simply the 1, and this is like we output now. And when we go into the rotation, into our graph here, and we see, and we disable the non-uniform scale, you see it's directly scaling up, because now we have disabled the non-uniform scale, so that we have, if we do not use the uniform scale, we switch. Pretty simple. Let's go, yeah, it's pretty slow. Let's go into the graph. 31 milliseconds. So the texture TG just takes more time than this, because it's 124. But if we 512, yeah, it's nearly the same amount of iterations through it. Okay, let's go into the non-uniform. Okay, now we have the switch of the non-uniform thing. Now let's go, and we want to add the rotation type, so that when we rotate it, we want to have it always centered into the middle. So this means, okay, we have 0.75 if it's 0. We have the degree. If it's degree 0, we have 1. If it's degree no, let's go 0. If we have 0, it's the uniform scale should be 1. If we have 0.1, no, it's like half of half, 0.12 something. We just type, if we have 45 degrees, we say like it's 0.125. If we have this angle, we scale it down. So what we need is to set some kind of sinus curve, but we want to have always the right values. So that means we use the same math we used for the rotation matrix, but in a different manner. Let me show it to you. We go into our graph, because now we only use, for this multiplication here, we only multiply the first and the third one for the uniform scale, and we use the sinus curve and multiply the sinus curve by a different way. So this is what we use for our scaling. Let's go into this one and we create an empty function from it, paste it in, and we go back and we just copy our graph here. Okay, we remember that the second and the third could be 0, or was it something? Let's add a new text Transform2D node and make it 75. So this is our rotation we need for the 45-degree thing, and we want to visualize the matrix. You see, it's 1.3. Is it right? Yeah, it's 1.3. So if it's 1, it's totally okay. Maybe we will make it in the other graph, but using this, and multiply this rotation thing directly, because then we do not get this scaling that we have here, a scale and there a scale. Let's go into the matrix and just adjust this a bit more. Okay, we want to have a new Boolean. Or let's have a new Boolean. This belongs to the rotation thing, and we call the Boolean. The input 2. Let's go up to the Boolean, and we call this one. How do we call it? This is our Boolean fix rotation scale, or fit rotation. Oh no, fix is a cool word. Fix rotation, and the label is fit scale to rotation. All we need is rotation. We call it true label fit to frame, and don't fit frame. Fit to frame. Okay, that is like it's true, it's false. Fixed rotation is our identifier. We go into our matrix here and we add a new Boolean. Get Boolean. And this is the fixed rotation. And again, just to visualize it, the rotation Boolean belongs to the group rotation. Okay, let's go. We have it, and we have don't fit to frame, fit to frame. It do not do anything at the moment because we don't have we don't set up the graph for it. But in the end, it's like, okay, we have this one, and if we do not add the scale mode, if we do or not, it's not important. The important thing is, again, if this identifier gets greater or equal to 0.07, no. If this is greater, then we need to find a mask to only set it in the frame if we rotate it. So I want to, but if this value just gets 0.75, like here we have 0.75 that fits, and if it's not fitting, he just cuts it. You see, and 0.75 is the right value, but when we change the angle to this value, we can use a greater scale, and if we use this, we can use complete 1, so that we scale it even if we have a lower scale itself. Then we go we need to calculate the difference, but first let's go and work with this fixed rotation thing. It's like, okay, we leave this out first and go with the fixed rotation. If we enable the fixed rotation, if we not, we go directly to this, and if we want to fix the rotation, then we multiply this value with another value. Go into my transform. Here I have no math in it. Okay, I just leave this one out. Let's go directly into this one. Yeah. Okay, we simply use the same math like we used before. Like we have P. Remember, sinus 1. This one is like sinus. We use the sinus curve, and we get it from 0 to 1. So remember, if we have 0.5, it's 1, and if not, it's not. Let me think about it. I think this will work if we have this. Take the sinus curve and we use the we use the linear interpolator, but we always also go into the negative space. We don't want to do this. This is why we use our output and multiply this by 0.5 and add 0.5 afterwards. 0.5 and we add 0.5 afterwards. So we shift the whole sinus curve. We make it smaller and shift it up. Like we make it smaller and shift it up so that we get from 0.5 to 1 to 0 to 1, 0.5. Maybe we go with the cosinus curve because it's offsetted by 0.5. That's a better way to do it for the scaling case, I think, if my brain do not prove me wrong. Okay, we use this as our lerp feature, and we lerp between 0.5 and 1. That means that we 0.75. That means that we just scale between this value and 1. So this is our, and we multiply the value by these two things. Let's, if it's scale mode. Okay, we can just simply go with this, and we just set a multiply, and we simply add this one to it. That should work. We'll review that. If I go here and I just fit this, okay, fit the scale, it do something else that's not expected, that we don't expect. Okay, let's review that. We have the cosinus. Let's pack that all a bit. Okay, it breaks it to total. Break this in total. Okay, we set this a bit higher from the level. Let's watch this. Set this a bit higher from the level, and so we have the cosinus curve. And if the rotation is 0, then we have 1. That's right. If the rotation is halfway done, we have 0. But this is not what we want. We want to have a more often. We want to have, if it's 1, it goes this way, and if it is 0, if we have a quarter rotation. So let's multiply. Let's take the cosinus and multiply it by 4. Let's make another one, another cosinus. We use this one, but first we just set a new multiply in it. Multiplication, and we just multiply it by 2 again, so that we get 4 times p. And then we get a cosinus. It's still wrong. Maybe I did something else to it. Okay, that do not do anything. Just keep this that way. Okay. Okay. Fit to frame, disable it. Now you see. It's getting and don't fit to. Now it's do not fit to frame, but it's doing the job. Maybe I did the wrong thing, but let's preview that. Okay, if we have 1, it's just in the opposite direction. So that's, maybe we can switch these two, and then it will work. So we have the scale of 1. Okay, It's scaling still too slow. Let's add 4 to it. And now you see how it rotates. It's just fitting, so the edge is fitting the frame, and when I click don't fit to frame, there is either just this one is a wrong thing. I just multiply it by 1 if scale mode is disabled. So this should work definitely. I don't know what's wrong with it. If it's true, it's red, and if I do this, I multiply it by 1, so it should be white also when I just put it in there directly. Okay. This is my scale mode. Okay, I just made the wrong decision. I need to go another way, so just put this in there, and this is not the fixed rotation. The fixed rotation should be here, and the scale mode should be here. So now it's better. Okay, and we uniform scale, non-uniform scale. Okay, I need to set these different. So we have a uniform scale, and when I scale it down, it's right, and this is. But now I need to figure out if it's wouldn't fit the frame. We need to set the value that we scale it down in the right into the right manner. So we need somehow something like to clamp it on the mathematical thing. But when I have it to 1, everything works fine, and if I disable fit to frame, it won't fit anymore. Okay, now it works like expected. I have this pretty nice tool. Okay, let's go just one step further and add more to it. Okay, it's pretty complicated. I have to think about it in a minute. I want to set this value here. Now let's break this a bit down. We want to have it a bit clearer. Okay, we take this here, just multiply this by 8. And duplicate this one, and we set this into this. Okay, let's check if it's still working. Fit to frame, works. Okay. I don't know if it really fits on this part. It fits definitely on this part, but not on this part here. That is strange, but maybe I need to just set a different lerb so that we get, or a multiplier, we get maybe I did it wrong. the linear interpolator is maybe not the right way. It was a fast way to do it. Wait, how much do I have to get 0.5? Okay, let's make it this way. We take 1 and divide it by 4. We take a float and we want to have a 0.25. That's a fourth. And I want to have it, if it's okay. Okay, now it's getting pretty weird. My mind is starting in. That's pretty hard to solve a mathematical problem while talking. If someone have an idea, just post it. Okay, 0.5 multiplied 4 times, but do we want to have it only multiplied 3 times, so that we get, if we have a value from, let's go back to my sinus curve, we have multiplied by 0.2, or no, so now it's no, it's not 0.2 anymore. Okay, that's the problem. We have the linear interpolator, but it works. It works close, but we have a mathematical error then, because we do not use it directly in the right manner, because we just make some modifications to the cosinus output. What we now do is, what I want to do is just, if I have 45 degree, like if I have, in this case, from 1, let's go this, 45 degree is on this pace, I have 1.33, no, 0.75. Okay. Okay, I multiplied it by 8 times, so that I get by quad p, getting this value. Okay, 0.75. Okay, I'm just stuck in my mind. I just have to really think about it in a moment. But now, we could solve it if we just rotate it from the beginning in a smaller value. Let's go and just make this 0.7. Okay, let's scale it a bit down, and then we don't have the problem anymore. Okay, it's just a different thing. Let's go and add the non-uniform scale to it, because we have a uniform scale and already a non-uniform scale, if we want to scale it in different ways. And we can add another mode if we want to scale pre-rotation or after the rotation. let's go into this. Let's set up the Boolean first, and we call this scale scale Q. Damn. Scale hierarchy. What is wrong in my head? That was too much math for today. Let's turn a bit. Okay. We call it pre-rotation and past rotation. Visible if, and it's only visible if the texture uniform scale is not true. Input scale mode. Scale mode is wrong. Okay, you do not. You have an error. That's the wrong. Maybe this works. Okay, need to check it in the internet. But okay, the algorithmic documentation is pretty good, and helps pretty much. So let's Boolean float into. You say something like this. No. Okay, how does it work? Okay, maybe it's simply this. Yeah, so okay, it's the scale hierarchy. It's only visible if the texture uniform, the texture scaling thing works, and we have the group scale. Let's try it out. Okay, we have this, and we have the non-uniform scaling, and we have past and pre-rotation, and we can set the uniform scaling and the past, the scale hierarchy thing. Okay, let's give it a proper name then, because you saw it, it's this one, but we want to have a label scale hierarchy or scale order. Let's make it scale order. Scale order. Okay, so it's visible if the scale mode is true, and with the scale order. Then let's go into our advanced Transformation2D. So we add first the pre-rotation, or no, past rotation. Transformation2D, and we need to have a non-uniform scale thing, and we use a float2 for that. The same like they have on the texture2D node, like you have here. It's the stretch, width, and height. But they can only use it this way. We make it with the slider from 0% to 100%. But we have a float2 then. Then we add a input, name it non-uniform scale, and it's float2, and we have sliders, and we call this simply scale, and it's the group scale. And again, we use the same thing from the scale order here. We use if the input scale mode is not, then we visible we view the float2 for the non-uniform scale, because otherwise it's a uniform scale and the float is okay for it. Yeah, that's the past rotation. Let's go and create an empty function. And we add a node, and we first get the vectors we need. We first need to get the booleans. The first boolean we need to have is the scale mode. And let's if else, if scale mode, we first need to set up our vectors, vector float2, vector float4, and vector float2. Just duplicate it, just like this. So we have our setup, and we set this as our output node. We make Transform2D node to check the matrix. So when we go in the matrix, it's this one is 0 and this one is 0. This is the scaling values, the x1 and so the x and the w value. I don't know why they separate them by this, because it's normally it's x, y, z, w for float4. Okay, let's go into our Transform2D node. So we have the scale mode first, and we want to have a vector2 out of it. So we want to get a vector2, get float2, and this is our non-uniform scale. And then we have another boolean. This is our boolean for scale order. So if the scale order is pre-rotation, that will returns. If it's pre-rotation, we get a float. It will returns 1, because we want to have. We need to have a float4, a float2, because all the calculations up from here will be in float2. So if we have this, we got this input here, and we swizzle float2, and why he's doing this one? Okay, not swizzle. We want to separate them. has to float. No. Oh. Okay, normally it's swizzle vector 1. I want to add, now it's right, I want to exit X, and just here I want to have Y. Now I add this one to this one and this to this one. Okay, it's simple. We have this two areas. Now set it in, and we set this as our output. And we have, if we use the scale mode, so if we use the scale mode, if it's scale mode, so we use the non-uniform, the uniform scale, then return 1 1. Get into this. So he checks it all upwards, what he have to calculate. And this is our non-uniform scale. Let's go back to our old graph, because we are silly, and copy and paste simply our function we have here. These two things here. Copy it into this one. Just over here. Okay, we don't need to have the scale mode thing. We already have that. And we simply have this divided by 1. 1 divided by this value. This is our way to go. And so this is not, so we need to have a float 2. I see that we need to first, this is the last step we have to do before we connect them. So we have to check both of these values to get the right offset. So this is something we don't, oh wait. There's the texture uniform scale, we don't need that. We need to go this 2 times. Simply by just dragging this one, and we want to duplicate this. And just this one again. So that we make 1 divided by this, drag this in there, and drag this into this. So this is for our, so that we have, okay. Now we need to completely just copy paste this thing in. Not only the first one way, okay. You need to copy it completely, because we also need to check if the x is lower than this value. Okay, just put this down here. Have it a bit organized. Okay, and the output into this one. So this is only for saving us to make any error. Okay. Okay, and this is our just graph. Okay, we have the scale mode, if else, just, and then return us this value. Okay, let's go and check this out. Okay, it seems the rotation didn't work anymore. Maybe I copied something out of this. That would be sad. it's all in there. Okay, now it works again. Fit. Okay, now he gets confused by the values we get now. Okay, need to double check this. Texture uniform scale, okay. The scale mode. Fixed rotation. Somehow I did something wrong. I really don't know what it is. Okay, it only works with the uniform scale because the hierarchy is different. Okay, if I check the scale mode later, then we get this issue that he just set the size to 1. So I will just change this. Just getting this into this and this into this. So I check first. Let's clean this a bit up so that I don't have that much mess here. Okay, now this works anymore, and when I got non-uniform scale, it's still the same. Path rotation. Okay, that all works fine. Let's go into the path rotation. Okay, the path rotation just do something wrong. First, I will just minimize, disable the rotation thing, and check my graph here. So what I do is I have the scale mode, and if the scale mode is true, if it's not, I need to set this value here. Scale order, if not, this way. Okay. So going to the normal rotation thing. Okay. Okay, again I destroyed it somehow. Maybe there is some wrong calculations in it. Back into the matrix, so it's 0 and this is 1, and if I go to this to 2, then we have this, and this to 2 is this. Okay, that works. It's the first and the fourth. Go here, just the first and the fourth, and if it's the scale mode, and then give me the scale mode output, give me this one, if this is lower than this, then return 0.1, and constant float, okay, 1 divided by this value. Here same thing, x and y. Maybe I have to switch them by y and x. Okay, this does something else. But if I simply output 1 and 1, it should fit. But it does not. So I have some error with this here in the end. Okay, I don't want to rotate them. This seems to be right. Okay, somehow I did something wrong. Okay, that was the reason. I need to set the 0, otherwise he do not get anything. Okay, so we have a non-uniform scale now. It should work like expected. So we have this one, and just disable the tiling. We have the rotation, and we can the non-uniform scaling later. This is the past rotation. You see that it fits always to the thing. So I have the past rotation, and I can set it to pre-rotation. Let's set it to pre-rotation. So we duplicate the same Transform2D node and set it to pre-rotation. And what we do is just simply the scale order here. We simply switch these two values here. If we go into this rotation mode, to the normal map, so we have the past rotation and the pre-rotation. So the pre-rotation is now it rotates with the scaling. See, and if we disable fit rotation, and we can set it to past or pre-rotation. Fit to scaling. So yeah, past or pre-rotation. Set this to non-uniform scale. So yeah, it's just doing what we expect to do. We have two things, so maybe just let's check if we can. Yeah, we have 10 minutes left. Maybe I find something in the use of the inputs of the graph. So I want to enable input images. Okay, maybe we can go somewhere here. Okay, that's input color or grayscale. Okay, let's simply make two graphs out of it, so that we go with this way or with the other way. Yeah, let's make a new input for this. We call this new graph. That's relative to parent, and map input switcher. Okay, add node, So map input node switcher, we have a boolean, and we call this input mode. We'll label it as input mode, and we say color or grayscale. So okay, and we add node grayscale input image, and input color, and this is visible if input, the grayscale is if it's not input, and you're visible if the input mode is red. And when you set output, so you're visible if the input is this way, and you're visible if the input mode is wrong. And you're just always RGB luminosity, and you're always RGB alpha 32-bit. We can have more, but it's not important for maybe for normal maps. Let's go default format. Okay, that's it. So we have a map input switcher. We go here and have the map input switcher, and we have the grayscale mode or the color mode, and okay, but we want to have both visible, so it's more bypass. Then we want to have a switch there, so what he should output. So we have the color input and the grayscale input, and now when we switch the output, okay, it gets the connection there. Maybe we can have some switch or something. Add node. Gradient map. We expose the grayscale thing. Okay. Color mode. We can just set it by the input mode. There we input always a grayscale. Okay. Okay, that's our output. We do not visualize anything. No, that's not working. How do I manage that input switch? Okay, I will go with this and just set this in my advanced transform thing. Okay, yeah. I think that was it for today. Hope you learned something. Yeah. Hope to see you next week.